Okay, good morning, everybody. So the topic of today's lecture is basically we're looking at lists. So in Python, you know that you've all used a Python list, I hope. If not, if you're a Java-only programmer, there might be one or two of you in here. This is basically arrays today. So Java doesn't have, well, hang on. So a Python list is sort of like a mashup between two different things in Java. Right, so in Java, Java's got something called an array, and it's got something called a list, right? But the Java list doesn't really work the exact same way as a Python list. And what a Python list is, it sort of takes the syntax of arrays and mashes it with the capabilities of an actual Java list. Right, so a Python list is sort of it takes the best of both of the two things that Java has to offer and mashes it into a single class. And the Python list, I have to be, I mean, it's a lot nicer to use than either Java arrays or Java lists. Java lists aren't too bad, but you have to get used to using them. Okay? So you know that in Python, right, you can just write down a list using square brackets, right? So there's something called a list literal exists, right? You can write down a list and the contents of the list. You can access an element of the list using these square brackets. Right? So t square bracket 0 gives you the first element of the list. If you want the last element of the list, then the hard way to do it in Python is to get the length of the list, subtract 1, and use that as an index. Right? You should know that the easy way to do it is just use -1. Right? So Python has negative indexing. You can assign elements of the list, right, using the square bracket notation. Right? So t square bracket 1 equals b means change the lowercase b to an uppercase b. Right, and t square brackets 2 equals big capital C means change the lowercase c to an uppercase c. Right, and so Python lists are actually really easy to use in terms of syntax. Okay, so like I said, so Java doesn't have that nice syntax for lists. Right, so Java has something called an array. Right, and in an array, it's a container for objects. And it holds a fixed number of values of a single type. Right? The other thing I didn't show you back here in a Python list is you can shove whatever you want into the list. Right? So you can write t square bracket 3 equals some new list. Right? So you can put a list inside of a list, and Python doesn't care what it is you put in the list. For both Java lists and Java arrays, Java cares what you put into the list or the array. Right? So in a Java array, the elements all have a single type. They all have a single common type. And the length of the array is established when the array is created, right? So in a Python list, right, back here, you can append to the end of the list, right? You can either use the append method. Well, you should use the append method when you want to add an element to the end of the list, right? And you can insert into the middle of the list, and you can do all sorts of things. You can't do that with an array, right? So an array is a fixed number of elements, right? And you can't change that number once you make the array, right? So to declare the array, you use this notation where you put the type of the element, right? So double is the element type that I want to store, right? And then you put some square brackets after it with nothing in between, right? And then you give the name of the array, right? So that says that collection is an array of double values, right? I still don't have an array yet, though, right? All I have is a variable that can hold an array, but I don't have an array yet. Okay? Now, a Java array is, so you see in brackets, it's a lot less flexible than a Python list, right? But the reason I'm telling you about arrays is because Java arrays, they also use the square brackets for indexing, right? Now, what do I mean about far less flexible? Well, I mean you can't slice an array like you can slice a list in Python, right? You can't use negative indexing on an array, right? So you know that to get to the back element of the array, you can just use the index -1 in Python, right? The second last element is just -2. Right? Can't do that in Java. If you try to do that, you'll get a runtime error. So the compiler won't even catch the error. Right? You have to compile your program, and then when you run it, your program barfs. Right? And you have to specify the element type. Right? So here, I've got this thing called, I've got an array of, I've got an array of car, right? And I can only put cars into this array. All right? So what's car? The way it's written here, you would think that cars are single single characters, right? That's what it's supposed to be, right? So you can have a single letter, number, digit, whatever, right? You can have a single letter, digit, or any other character, any other single character, right? Inside the single quotes, right? So that looks like this array holds the letters A, B, C, and D. Right? In reality, what it's actually holding are numbers, right? So those letters are actually mapped to numbers in some integer value. And I actually don't know what the integer values of those are off the top of my head. But they're just integers underneath the hood. Right? And then you can use, to get the first element of the array, right? It's the same syntax that you'd use in Python. Right? So T0 is just the lowercase a. Right? Again, to get the last element, right? Almost the same thing. Right? There's no len function in Java, right? Because there's no functions at all in Java. So what there is in Java is if you have an array, t, right? You can use t.length to get the length of that array. Right? So t.length in this example is 4. Right? 4 minus 1 is 3. Java uses zero-based indexing, so 0, 1, 2, 3, right? And that's the D. And then you can do assignment the same way you do in Python, right? So the second element of T is now the uppercase B. The third element of T is now the uppercase C, right? So syntax is very similar to a Python list. Yes? Sorry, can you repeat that? Is collection a specific keyword or is it a variable? No, here's a variable. Yeah, here it's a variable. OK, so an array can initialize its size and its elements by writing the elements in a comma-separated list. Right? So it looks like there are these things called array literals, but there aren't. Right? You can only do this when you declare the array. Right, so if you wrote down brace A, B, C, D and just left it somewhere, right, the compiler wouldn't accept that as a legal Java code. Right? This is what's called an array initializer. Right? It looks like a literal, but it's not. Okay? So you are allowed to do this when you first declare the array. Right? You can't even do it on the next line. Right? So you can't write car square bracket u, and then on the next line say u equals something. Right? The compiler will complain. Oh, excuse me. The compiler will complain. Right? So you can initialize the array, but you're only allowed to initialize the array using the brace notation. Okay, so that's not the normal way to make an array, right? So using this, you're allowed to use the braces to initialize the array, but it's not the normal way to make one, right? Because it's somewhat unusual to have small arrays, right? Normally, when you have an array of stuff, it's often large. So you don't want to go to writing down all the elements of the array. So the normal way to do this is you use what's called the new operator, and then you specify how big the array should be, how many elements you can put into the array, right? So that's called the capacity, right? Or the length of the array. Right? So the capacity or length is the maximum number of elements that you can put into the array. Right, okay, so how do you do this? Right, so same code as a few slides ago, right? Double square bracket collection. So collection is an array of double values, right? Well, that's actually not true. Collection is a variable that can store an array of double values, right? There's no array yet, right? The array isn't created until the next line, right? So when I say collection equals new double square brackets 10, right? That means, so new double 10 means make me a new array of size 10 that can hold a bunch of doubles, right? And then assign that array to the variable collection, right? And so now you have an array, right? No array yet. What you have is a variable that can store an array. Once you say new double 10, now you have an array. And now you can use collection as though it were a regular array. Right? So you can see that Java is a lot more verbose than Python. Right? Python, you can just write collection equals square brackets and away you go. Right? And then you can stuff whatever you want into the list. OK. Now, when you make that array, right, you've now got an array of 10 doubles. So the question is what's sitting inside that array after you make it? Right? In some languages, like C, which is one of the predecessor languages to Java, you don't know what's in the array. Right? In other words, the contents of the array are uninitialized. Java says when you make an array of primitive type, it's going to be initialized. Right? So when you make an array of primitive types using the new operator, all of the elements of that array are assigned a value. Right? So I've got 3 arrays here. Right? Some bools is an array of booleans. Right? It can hold 3 boolean values, 3 true-false values. Some ints can hold 4 int values. Right? And some doubles can hold 5 double values. Right? If you print out the array, and this is how you print an array. Right? So you use print or println. Right? You then call the method toString that lives in the class arrays, right? And you pass it the array that you want to print. Right? So what toString does is it takes the array and it converts the elements of the array into a string representation of the elements. Right? So in other words, it prints out something similar to what you would get in Python if you printed out a Python list. Right? You get square brackets, you get the elements separated by commas and spaces. Right? Now, arrays is another class, right? It's a class that's part of the Java standard library, right? So you have to import that class before you use it, right? So that's why the import statement is on this slide, right? I have to import java.util.arrays. Then I can call arrays toString to print out the array. OK, now if you do this, right, some bools is an array of Boolean, right? 3 Booleans. So you're going to get false, false, false. So the default initialization value for an array of Boolean is false. For all the numeric types, it's 0. Right? So when you print out some ints, you'll get 0, 0, 0, 0. And for the doubles, you'll get 0, 0, 0.05 of those. Right? And there's the table of the default values for arrays. Right? So when you make an array, it's filled for you. Right? It automatically gets filled with some values. You cannot, unfortunately, change the fill value. Right? So it'd be nice if you could say, hey, I want to fill the array with a bunch of true values if it's a Boolean. Right? Or if it's an int, you might want to say, hey, I want to fill this all with 1s. But you can't do that, unfortunately. Right? Those are the values you get. Right? False and zeros. Now, obviously, there are many cases where you want to fill the array with some value, right? So something other than 0, for example, right? So here's our array sum doubles again, right? And this time it can hold 10 double values. If I print it out, I get 10 zeros, right? So the array is populated with all zeros. If I want to fill that array with ones, right, then again, I go to my handy utility class called arrays, right, and use the method called fill, right? And I tell the method, what array do I want to fill? Well, I want to fill the array sum doubles. Right? And you tell it, what value do you want to fill it with? Well, I want to fill it with ones. Right? And now when you print that out, you're going to get 10 ones. Right? So arrays, this class arrays, is what's called a utility class in Java. Right? It's the, you can, by looking at the name, you can tell that it's a utility class where all the methods operate on arrays. Right? That's why it's named big A, arrays, with an S at the end. Right? If you ever see a class in the standard library that's pluralized, right, like arrays, there's a collections, right, then that's a hint that that's a utility class that operates on the thing that it's named after. Right? So arrays, a bunch of methods that operate on arrays. Okay, any questions so far? Okay. The number of elements in the array is stored in the field called length. Right? So I already showed you this. Right? If I make if collection is an array of 10 doubles, later on I can get the length of the array. Right? I just write the array name dot length. Right? You cannot change that value. Right? If you wrote collection.length equals 10, or sorry, equals something else, equals 5, the compiler will flag it as an error. Right? It'll tell you you cannot change the value of the length of the array. Right? Which reinforces the fact that arrays have a fixed length in Java. Okay, so like a list in Python, the values in an array are called elements. The elements are accessed using a zero-based index, just like Python. Right? Unlike Python, there's no negative indexing. Which is super inconvenient, actually. That's one of the nicest things about Python lists, actually, is that you can get to the end of the array by writing -1. Right? Instead, if you want to get to the element at the last place in the array, you have to write a length -1, right? Which gets, it actually does get very tiresome to write this. Right? If you want to get the second last element, it's a length -2, right? Third last element, a length -3, and so on and so on. Right? I guess, it's shown in the caption here. Right? So that picture there is showing you an array of length 10. Right? So it can hold 10 elements. It doesn't tell you the type, which is fine. Right? And this row here is telling you the index number of each corresponding element. Right? So the first element 0, last index is 9, and that's because the length of the array is 10. Right? Right, so using a zero-based index, you can write something silly like this. Don't write this, but you can do this if you, but this is legal. Right? So assuming you have your array collection, right, you can set the first element just by writing collection square bracket 0 equals something. Right? You can get an element by writing something equals collection square bracket 0, right, just like in Python. You can do the same, you can do something similar for all of the elements for the, second, third, fourth, fifth, all the way up to the 10th element. Right? So collection 9, that's the last element in the array. Right? In Java, if you write collection 10 equals something, the compiler doesn't care. When you run your program barfs, and you get this error that's called an array index out of bounds exception. Right? So the compiler can't check this for you. Right? So when you're using arrays, probably the most important thing that you have to be aware of is that your indexes always have to be valid. Right? And the most common error that when working with arrays is that you're off by 1 somewhere, and you end up with an index that's -1, or it's equal to the size of the array, right? The length of the array. Right? So -1 is illegal. The length of the array as an index is illegal. Right? So you always have to be on the lookout for these illegal indexes. Right? It's super annoying because you can't catch the error until runtime. Right? You might test your method or whatever your code very extensively and never catch the error. And it's only under some strange circumstance that you end up with an index that's out of bounds. OK, what are we doing here? Oh, we want to do loops now, right. So those are arrays. That's basically all you need to know. That's almost all you need to know about Java arrays, right? The only other thing is how do you make a 2-dimensional or a 3-dimensional or a 4-dimensional array, right? And the answer to that is we don't care right now, right? But you can do it if you want to. So now what we want to do is we want to work with the elements of the array, right? And so you know that an array, like a list, is a collection of stuff. How do you process a collection of stuff? Well, often you want to process every element in the collection, right? So now I need a loop. In Python, the for loops are always for something in something, right? That's what a Python for loop always looks like, right? So here I'm looking for the maximum element in this list T, right? I start by assuming the maximum element is the first element in the list, right? And then I look at every element in the list, right? So for every element in the list, if a particular element is greater than the current largest element, right, then I found a bigger element, right? So I assign high equals elem, right? And you just keep on going around and around and around, right, until you process every element in the list, right? And then when you're done, you can return high. And that is the hard way to find the maximum element in the list in Python, right? The easy way is to use the max function, right? So max t gives you the maximum element. But the reason I'm doing this is so that you can see what this looks like in Java now, right? Java has what's called a for each loop, right? So back here, you can think of the Python loop as being a for each loop as well, right? For each element in T, right? For each. Java added a for each loop in Java version 5, right? So it looks a little bit different than the Python loop, but it's doing the exact same thing. OK, so let's take this apart line by line, right? All of our methods right now are public and static for the time being, right? Oh, the other thing about this, the Python loop, the Python version, you can pass in whatever list you want. Right? You can pass in a list of int. You can pass in a list of floats, right? And this works, right? Java, you have the problem where I have to pass in an array, and all arrays have types. So I now have to specify the type of the array, right? So here I can find the maximum element in an array of double, but I can't, using the same method, I can't find the maximum element in a list of int, right? I have to replicate the method and change the type from double to int, right? Way at the end of the course, you're going to see how we can get around that problem. But for now, if you wanted to find the maximum element in an array of, say, longs, you would have to reproduce this method, changing every double to long, right? So again, that's another difference between Java and Python, right? But the code works the exact same way, right? I'm going to start by assuming the largest element in the array is the first element, right? And then for every element in the array, right? And that's how you write the for loop on the previous slide, right? For each element in T, that's how you write it in Java, right? Starts with for. You must have the round brackets, right? You need the parentheses, right? You need a variable here, right? So elem. You need the colon, and then you need an array on the right-hand side of the colon, right? And then in front of elem, you need the type of element that's in the array, right? So that says for each double element in the array ARR, right? Brace, and closing brace down here, right? And then you have your if statement, right? So this is just the corresponding if statement in Java, right? If elem is greater than high, then high is now equal to elem. After you process all of the elements in the array, you've got the largest value in the array, right? And away you go. Does anybody see what's wrong with this code? Anybody? There is one problem. It's on line 1, actually. It's here. Anybody got it? Yes?
Void.
Sorry, what void? The method. When I declare the method? No. This method returns a double. It has to return, right, it's going to return the largest element in the array. And that element's going to be a double. So it's not void, it's something's wrong with double high equals array 0, equals ARR 0. Okay, so in Java, there's the notion of the empty array, right? So an array having no elements. An array having no elements has no first element, right? So if you pass in an empty array, this method will stop at runtime with an index out of bounds exception, right? Here, you really need an if statement, right? Before you do double high equals array 0, you need an if statement to check if the array has an empty length, has length 0. Right? And if it does, you have to do something else. But we're not worried about that right now. Okay, but there is a potential error here. Oh, wait, back here. Remember, so in the last class, I talked about the scope of a variable, right? So when you use a for each loop like this in Java, the scope of the variable elem is the body of the for loop, right? I can't use it after the for loop, right? Because I declared the variable as being part of the for loop, right? If you want to be able to use elem after the loop, before the loop, you have to write something like double elem equals something, doesn't matter what. And then inside the loop, you would just write for elem colon array, elem colon ARR, right? And that lets you use elem after the loop. Right? But if you write it like this, you're stuck with the scope of elem being just the body of the loop. Normally, that's the way you want to do it. It's unusual to want to use a loop variable after a loop is finished. Okay, anybody have any questions so far? Right, so that's, it's not too difficult to go from the Python to the Java here. Right? You just have to get used to the syntax, right? That changes a little bit. In many situations, you want the loop variable to correspond to an index of the element, right? So there's a lot of cases where inside the loop body, I want to write t square bracket something, right? In other words, I want the index of the element that I'm currently accessing, right? So you can think of this in Python as being a loop that uses a counter, right? 0, 1, 2, 3, 4, 5, up to the length of the list. Right? And you know in Python, you use this handy thing called range. Right? So for I in range 0, comma length t gives you the sequence 0, 1, 2, 3, 4, 5, 6, length t minus 1. Right? And then those are all valid indexes for the list t. So I can write ti in this case. Right? T square bracket I. Right? This is the exact same function as max elem, except this one doesn't return the maximum element. It returns where the element is inside the list. Right? It returns the index of the maximum element. Right? So it's the exact same code, except you insert index equals I here. Right? And then you return the wrong value. Sorry, my bad. You return here I. I have to return index, right? Yeah, I want to return the index. Right. Okay. So that's what I'm going to call a counting style loop in Python. I don't know what you actually call it, or if it even has a name. Right? That's a counting style loop, though. Right? You're going to count from 0 up to some number. And here, this is the only way you can actually solve this problem if you're trying to write your code yourself. Right? I need the index of the element. Right? So if I'm going to avoid looping over the list twice, then the only way I can get it is if I have some loop variable that changes each time, and it corresponds to the number, the index of the element that I'm looking at. Right? Oh, sorry. Oh, hang on. You're going too far. OK. Now, if you want to do this, right, Java has another kind of loop that lets you do this. Right? Java doesn't have a range. This looks like a function in Python. Right? For I in range, that's actually not a function. In Python, you're actually making a range object. And the range object knows how to count from 0 up to the length of t minus 1. Right? That's actually a constructor call in in Python. So Java doesn't have that. Java doesn't have range objects. If you're reading the notebooks, though, I forget where. I think it's somewhere in part 2. Towards the end of part 2, I show you how to make a range object. But the correct way to do this in Java is to use the older style of loop. Right? This was actually the only kind of loop that was available until Java 5. Right? So here is a loop. This is the exact same code as before, right? Except now I'm keeping track of the index. Sorry, hang on. Delay is one. And let me just check the audio on the live stream. Sorry, hang on. Right. So now I'm keeping track of the index. Right. Now my loop says, now it looks like something else. Right. If you're a Python programmer, this looks like a mess. Right. Python loops are much easier to read. You have to get used to this, though, because this is the standard loop in Java. Right? If you're going on to second year computer science, it's the standard loop in C as well. So it's the only loop in C. Right? OK, so this one reads for int I equals 0, semicolon. I is less than array.length, semicolon, I++. OK? You need the semicolons here and here. Right? You cannot leave out the semicolons. I is my loop variable. Right? So the scope of I is the body of the loop. Right? Now that I've got my loop variable I can use it just like an index. Right? So if array I is greater than high, then I found a new largest value. Right? So the index of the new largest value is just I. The value of the new largest value is just array I. Right? Go through all the elements in the array, and by the time that loop is done, I've found the index of the largest element. Right? So now we have to take apart this for loop so I can show you the parts of the loop. So a for loop in Java has 4 main parts. Right? It has what's called an initialization expression. It has what's called a termination condition. It has a third part, the update expression. And then it has a loop body. Right? Every time I write, almost every time I write a loop in this course, it's going to have all 4 parts. Right? However, you do need to know that parts 1, 2, and 3 are technically optional. In other words, you can write a loop where there's no initialization condition, termination condition, or update expression. It is possible to do. The language will allow it. When you go to write such a loop, and you will do so sometimes, then, well, in the future, you'll do so sometimes. The 2 semicolons, you have to put them in even if you're missing parts 1, 2, or 3. Right? The 2 semicolons are always there. So the initialization expression, that's the int I equals 0 part. Right? So what does that do? That declares your loop variable. And it initializes the loop variable to 0 in this case. Right? So all it's doing is making a variable for the loop, right? And setting its initial value. OK? So I'm going to start out the loop. I'm going to have a loop variable called I. The starting value of I, so I, the first time the loop runs, will be 0. OK? It's the initialization expression runs exactly once. Right? So we only ever initialize the variable once. Right? It runs the first time. It runs when it hits the for statement. Right? So when it's running, it hits for, it initializes I to 0. Right? That's where you declare your loop variable. 2, the termination expression. So the termination expression, if the termination expression is true, right? If the value is true, then the loop runs. Right? So if I is less than the length of the array, then the loop body will run. Right? This condition gets checked every time you start a new loop iteration. Right? So the first time the loop runs, I is 0, and then we check the condition. Right? Is 0 less than the length of the array? Let's assume yes. Right? Then the stuff in the body of the loop will run. Okay? When that termination condition evaluates to false, right, the loop stops running. Right? So if I is less than array length is false, you end up down here. Right? You just skip over the body of the loop, and the loop stops running at that point. OK, so if you have an array of a length 10, right, when I is equal to 10, right, that condition is false, and the loop will stop running. Right? It will not run the 11th time. Right? Part 3, the update expression. So the update expression gets evaluated right before that end brace. Right? So after all of your code in the body is there, then that I++ gets evaluated. Right? As a Python programmer, I don't think you have ++. Do you have ++ in Python? I don't remember. No, you don't, right? Yeah, you don't have plus plus in Python. I plus plus means, in this case, it's the same thing as saying I equals I plus 1. Right? Increment the value of I by 1 upwards. Right? There's also an I minus minus, so let's decrease the value of I by 1. Technically, it means something, the actual definition is a little more subtle, but for now, increase the value of I by 1. Right? So, first time the loop runs, I is 0. Right? Check the condition. The condition is true, run the body of the loop. Right? So the body of the loop runs. At the end of the loop, I now has the value 1. Right? I gets the value 1. So now when you come back up to the next iteration of the loop, it checks is 1 less than the array length. Right? If yes, then the body runs. I gets updated here. Now I is 2. Right? And so on and so on and so on. Right? So instead of using range, you've got to manually keep track of this loop variable yourself. Right? You have to manually start its value. You have to manually tell how to update the value. And you have to specify the condition where the loop should run. OK, so when do I need to use the second form of that loop? Right? So if the body of the loop needs access to an index, right? Or if it has to access more than one element of the array, then you probably need to use the second type of for loop. Right? So this one, I'm writing a method called isSorted. It's going to check if this array is in sorted order, right? Smallest to largest. Okay? I'm going to start out by assuming that the array is in fact sorted, right? So isSorted gets set to true. I'm now going to look at every adjacent pair of elements in the array, right? So I'm going to look at the first and second element of the array, right? I'm looking at 2 elements, so I have to use this counting type of loop. Right? Now, you can start counting at 0, but here I've chosen to start counting at 1. Right? So I'm going to start the index at 1. Right? And what I'm going to do is I'm going to use that index and the index I minus 1. Right? So element I and the element in front of it. Right? In this case, so the first time the loop runs, this will be 0, and that'll be 1. Right, so I'm going to compare the first 2 elements. If the element in front, if element 0 is bigger than element 1, well, the list isn't sorted. Right? So I can set isSorted to false. Run through all the elements in the array, right? And then return the result at the end. Right? So if everything's sorted, if the list is in fact sorted, this condition in the if statement is never true. So isSorted never gets set to false, right? If you ever encounter a pair of adjacent elements that are in the wrong order, isSorted gets set to false, right? If you need a picture of what this looks like, here it is, right? So in iteration 1, I is 1, right? I minus 1 is 0, so I'm going to compare the 12 and the 13, right? Is 12 bigger than 13? The answer is no. So go to iteration 2, right? I goes up by 1. So I is now 2, right? I minus 1 is 1. Is 13 bigger than 14? The answer is no. So keep going. Right? Iteration 3, I is now 3. Right? I minus 1 is 2. Is 14 bigger than 15? The answer is no. Keep going. Right? I'm going to skip over all the intervening elements. Right? This is iteration 14. So I is now 14. I minus 1 is 13. Is 25 bigger than 26? The answer is no. One more iteration, right? Is 26 bigger than 27? The answer is no, right? And now the loop condition, the termination condition runs, right? Because at the end of the loop, I gets set to 16, right? And 16 is not less than the length of the list, right? So the loop stops running, right? And in this case, it returns true, right? The list is sorted. OK. In this particular example, you should have realized that once you realize the list is sorted, is not sorted, you're finished, right? As soon as you find any adjacent element that are out of order, right, you're done. You don't have to look anymore, right? So I don't have to process the whole array. I only have to process the part of the array up until I find a pair of elements that are out of order. If you want to break out of a loop, the statement is break. Okay? So break here means that if you get to this break statement, you know the list is not sorted, I can stop processing the array. Right? Break will cause program flow to go to the end of to go past the loop body. Right? So now this just returns false. Okay, any questions so far? Super. Right, so here's iteration 3, right, of this example. Right, I is 3, I minus 1 is 2, 99 is bigger than 15, so you hit the break statement and away you go, right? The loop's done. Okay, here's another example of when you have, here's another example of when you're accessing more than one element at the same time, right? So again, I need to access 2 elements of the array in this example. So I probably have to use a counting style loop. This method is going to reverse the elements in this array A. Right? So it's going to take the first element and swap it with the last. It's going to take the second element, swap it with the second last, and so on and so on and so on. Right? So J, that's going to be the element at the right-hand side of the array. Okay? I will be the index at the left-hand side of the array. Right? I'm going to start at the first element, so I equals 0. Right? I'm going to ignore the termination condition for now. Right? I'll explain that in the next set of slides. And all you do is you just swap elements AI and AJ. Right? So how do you swap anything in any programming language? Well, if you're going to have to do it the hard way, right, you introduce a third variable. Right? So temp, I'm going to remember the value of AI. Right? Next line, I'm going to copy AJ into AI. Right? So I've lost the original value of AI. Fortunately, I have a copy of it back here. Right? So then I can then put temp back into AJ. Right? And then, right, so J is the thing at the end, right? So I is counting this way. J is counting this way. Right? I gets updated up here. J gets updated down here. Right? Which looks a little inconvenient, but I'll show you something in a second. So J minus minus is decrease the value of J by 1. Right? Why does this work? Well, here's a picture. Right? So at iteration 1, I is at the front, J is at the end. Right? I'm going to swap those two and then go to the next iteration of the loop. Right? So now I is 1, J has decreased by 1. Right? It's moved to the left. And I'm going to swap those two. Right? I goes up by 1, J goes down by 1, swap those two. Eventually, you hit this situation. Right? So this is iteration 8. Right? I is less than J still, right? So I is still to the left of J. Right? So I'm going to swap them. If you ran the loop one more time, right, J would now be in front of I. Right? So if I run one more time, J goes down by 1, I goes up by 1. Right? And now you've gone too far. You're going to start swapping all the elements back to the original. Right? So the termination condition here is you run this loop as long as I is less than J. Right? If you have an odd length list, I will be equal to J, but it doesn't matter because there's no swapping. Right? If you have an odd length list, you don't do anything with the middle element. Okay. Now, in that example, there's actually 2 loop variables, right? I and J. And they have the same type. Right? If that's your situation where they have the same type, and it's not always the same situation, it's not always that situation. But if it is, you're allowed to declare both of your loop variables in the initialization statement. Right? But they have to be the same type. That's the big limitation to this. Right? So I can write I equals 0, comma, J equals A length minus 1. Right? Because they're both of type int. Right? If J was some other type, you can't put the type in front of the J. The compiler will complain. It'll tell you you're not allowed to do that. Right? Similarly, if they're the same, you can update both of the things in the update expression. Right? So I plus plus comma J minus minus means at the end of the loop, increase I by 1 and decrease J by 1. Right? So that's the cleaner way to write this loop than the way I just showed you. Right? Although if you could write the previous loop, I would be thrilled. On your own, I would be thrilled if you could do that at this point in time. Okay? All right, any questions there? Yes?
I'm really sorry to ask this
So that would be the same thing as saying def reverse a in Python. It's defining a method, right? So there are no functions in Java, right? So you have to get used to saying Java methods, right? The closest thing to a Python function is a public static method in Java. So for now, everything's just public static. Void means it returns nothing, right? Whereas in Python, you never say what the return type is, right? So, okay. All right. What is this? Oh. There's another case where you have to use the counting style loop, right? If you're processing more than one array with the same loop variable, you have to use a counting style loop, right? Because the for each loop only loops over the elements of one array, right? So here I have 3 arrays. I've got A and B, and I want to add the elements of A and B together, right? So A0 plus B0, A1 plus B1, A2 plus B2, and I want to store the results in C, right? So if I want to store the results in C, I have to make an array called C, right? So int square bracket C equals new int A length, right? In other words, I need to make an array C that has the same length as the array A, right? Then I can write my loop, right? So int I equals 0, I is less than the length of A, I plus plus. And then you can write CI equals AI plus BI. And away you go. Then you can return C, right? So Java methods can also return arrays, right? So this method returns an array of int. And in this case, it returns the array C. All right, almost there. Slicing, right? So you know that in Python, you can slice a list, right? So you can grab a sublist of a list in Python, right? Super handy in Python, right? You cannot slice so in this example here, right, I'm going to grab the elements 2, 3, and 4. Right? Not 5, right? Elements 2, 3, and 4, right? The Python slice does not include the last number. So that gives you elements 2, 3, and 4. You can't slice in Java, right? There's no slice operator for arrays. So what you have to do is you have to write your own method, right? And so the method looks like this. If I'm going to slice this array of integers, right? What does that mean? Well, I'm going to get some part of that array. So I'm going to return another array. Right? Start, that's the index where the slice starts. Stop is the index 1 after the slice stops, right? The same as in the Python example, right? So the slice does not include T5 in this example, right? So it's going to be the same thing over here. All right, now in Java, so I want to slice assuming start is less than stop. So I want to grab start, start plus 1, start plus 2, up to stop, right? But if I'm going to do that, that means start has to be bigger than stop. Otherwise, it doesn't make any sense, right? So I'm going to check. If start's greater than stop, I'm going to say that there's an error, right? And the way that you indicate an error in Java is you throw what's called an exception, right? And that's how you throw one particular type of exception, right? In Python, you would raise an exception. Java says you throw an exception. The syntax is throw new and then the name of the exception, right? So here I'm going to use what's called an illegal argument exception. It's the most common exception you'll see in this course, right? If you think about this example for a few minutes, you'll realize there's other things you should be checking for, but I'm going to ignore those for now. How do I make the slice, right? So you have to think, well, how many elements are in the slice, right? So back here, 2 and 5, right? You can see there's 3 elements in the slice. So the number of elements is just the stop minus the start index, right? It's just 5 minus 2, right? So how big is my array? Well, it's just stop minus start elements long, right? I have to make an array that can hold that many elements. So new int blah, right? And now you just copy the elements of the array into your new array slice, right? But you have a small problem, right? You're copying the elements from start, start plus 1, start plus 2, up to stop minus 1, right? But your array slice is indexed 0, 1, 2, 3, 4, etc., right? So array I, that's the element I want to copy out of the original array. The corresponding element in the sliced array is I minus start, right? So when you start the loop, I is equal to start. So slice 0 gets set to array start, right? Next loop iteration, slice 1 gets set to start plus 1, array start plus 1, right? Next iteration is slice 2 gets set to array start minus 2. Start plus 2, I'm sorry. Right? And so on, and so on, and so on. So I'll let you read how to call the Java version of slice so that you know how to use it. That's the next slide. And then that almost takes you up to what you need to do assignment 1. Okay? So assignment 1 will appear later this afternoon, where you translate a modest-sized Python program into a modest-sized Java program. Everything you need to know is in the slides, right? I promise you. Sorry? It's like a week and a half. Yeah, you got lots of time to do it. It's literally straight translation. So if you read the slide, translate the Python using what's told you in the slide, you'll be fine. Thank you.